zeros of polynomial functions. Our objective here, we want to algebraically, so we're not going to make use of our graphing calculator. We're going to do this algebraically. Find the zeros, and we're going to stick to third degree polynomial functions. A bit more complicated as things get to fourth degree and fifth degree. We're just going to simply stick to third degree in this video. And of course, they need to have integer coefficients because we're going to make use of the rational zero theorem to help us with this. So we need to have integer coefficients in our third degree polynomial. We know a lot of things. Let's go over those briefly. We know what a polynomial function is. F of x is equal to all of this. A sub n is the coefficient of the variable to the highest power. It's also called the leading coefficient. A sub 0 is the constant term. And of course, if this is written with the powers in descending order, it is in standard form. We've seen synthetic division. It's a shortcut method of polynomial division that can only be used if the divisor is linear. In other words, x minus c. And don't forget, we're doing minus c. That's how this works. We've learned in a previous video the rational zero theorem. Again, if a polynomial has integer coefficients, all possible rational zeros are of the form a factor of the constant term divided by a factor of the leading coefficient. And we know the quadratic formula. It's a formula x is equal to negative b plus or minus square root b squared minus 4ac, all divided by 2a, that can be used to solve any quadratic equation. As we remember, some quadratics are factorable, most quadratics are not, and so you have to use the quadratic formula to come up with the answer. Okay, to algebraically, again, we're not going to touch our graphing device. To algebraically find the zeros of third degree polynomial functions that have integer coefficients. So we're being rather specific here. We want to use the rational zero theorem to list all possible rational zeros. We then want to use synthetic division to test each of them to see if there is a rational zero. Note, we're doing third degree polynomials, and every odd degree polynomial has at least one rational zero, okay? And then we want to factor or use the quadratic formula to find the other roots, okay? So those are our steps for this. Let's do it. It'll make a whole lot more sense when we see an example, of course. Okay, so let me slide this down a touch and get it up here for you. Okay, find all the zeros of this third degree polynomial with integer coefficients, x cubed plus 7x squared plus 11x minus 3. Okay, so here is our constant. Its factors are positive and negative 1 and positive and negative 3. Here is our leading coefficient. It's a 1, and its factors are positive or negative 1. So, step 1, we got to find our possible rational zeros. Okay, well, that's going to be equal to the factors of the constant term, so positive or negative 1 and positive or negative 3, divided by the factors of our leading coefficient, positive or negative 1. Well, that's going to be positive or negative 1 over positive or negative 1, and positive or negative 3 over positive or negative 3, which tells me I'm going to have either positive or negative 1 or positive or negative 3. I have 4 possible rational zeros that I need to test using synthetic division to see which one is an actual. Okay, so now we're going to use synthetic division. Okay, we're going to test, and now we're going to use synthetic division, T-H-E-T-I-C, division. Okay, let's test +1. Okay, so put my 1 over here. My coefficients, I have all, this is cubed, squared to the first power. So my coefficients are 1, 7, 11, and -3. I'll pull the 1 down, and I'll start my process. 1 times 1 is 1, put it here, add, I get 8. 1 times 8 is 8, put it here, add, I get 19. 1 times 19 is 19, put it here, add, I get 16. And this is not equal to 0. So 1 is not a 0. It's not a possible 0, +1. Let's test -1. Again, I'll use my coefficients. 1, 7, 11, -3. As you recall in a previous video, we did this with our graph. Well, we're not going to use our graph here. We got to find our 0 using synthetic division, using algebra. Bring the 1 down. -1 times 1 is -1, add, I get 6. -1 times 6 is -6, add, I get 5. -1 times 5 is -5, add, I get 8. This is not equal to 0. So neither -1 or +1 is a rational 0. Let's continue. Got to test 3 and -3. Let's test 3. Oops, I forgot. This was a test of -1. Let's test +3. I'll put 3 here. I'll write my coefficients. I'll bring the first one down, and I'll get started. +3 times 1 is 3. 7 plus 3 is 10. Repeat. +3 times 10 is 13. Whoa, not 13, that's plus. +3 times 10 is 30. I'll add, I'll get 41. +3 times 41 is 123, and yes, how to use a calculator. I'll add, and I'll get 120, and that's the remainder. Well, that's not equal to 0. So +3 is not one of the rational zeros. Okay, let's hope that -3 works. Should work anyways. Okay, we'll put -3 in here. Let's copy the coefficients and let's repeat the process. You can see how this is not done. It's helpful to have a graphing calculator. This is a tough thing to do by hand if it gets too complicated. This example is fairly simple with only the 4 possibilities. Okay, let's repeat. Let's bring the 1 down. -3 times 1 is -3. 7 and -3 is +4. -3 times +4 is -12. Add these two, I get -1. -3 times -1 is 3. Add, I get 0. Yay! Yeah, I got a 0. Okay, so what does this mean? -3 is a 0 because I have a 0 remainder. So this means that x minus -3 or x plus 3 is a factor. Okay, so what does that tell us? You can see why I gave us both a whole piece of paper. Okay, so this tells us, okay, that x cubed plus 7x squared plus 11x minus 3 is equal to x plus 3, that's a factor, and then these are the coefficients for my second factor right there. And that would be x squared, 1x squared, plus 4x minus 1. And of course, to find all the zeros, we want to set this equal to 0. Well, this is pretty simple. x plus 3 is equal to 0 means that x is equal to negative 3. We knew that. Okay, that's one of our 3 zeros. The other 2 zeros, I need to factor this or use the quadratic formula. Well, this is not factorable. X squared plus 4x minus 1 equals 0 is not factorable. So I need to use the quadratic formula. Okay, so the quadratic formula, I'll abbreviate it, is negative 4 plus or minus square root. B squared is 16 minus 4 times A times C, all divided by 2 times A. And I'm going to shortcut all this and tell you that the answer is negative 4 plus or minus, I'm not shortcutting too much. Whoops. Well, I'm doing it out obviously, over 2, which gives us negative 2 plus or minus the square root of 5. So I simplified this. This is 2 root 5, and then I divided both of those by 2, and that's my answer right there. This is a real number, but it is not rational. Okay, so my solution set. Okay, negative 3 is the smallest number, and then I have negative 2 minus the square root of 5. Hope that's correct. Maybe I got these, maybe they're not least to greatest. And then negative 2 plus the square root of 5. So it turns out I have 1 that's rational, and I have 2 that are irrational, okay, in this. So that's how you do all this. Again, we're doing it only with a 3rd degree polynomial that has integer coefficients, because as you can see, the 3rd degree polynomial takes a lot of work. And to go to 4th degrees and 5th degrees, there are easier ways to do it. But this is the way to algebraically do it with a 3rd degree polynomial. Okay, a quick recap. List all your possible rational zeros. Use synthetic division to find out which one is an actual rational zero. Rewrite your original 3rd degree polynomial as a multiplication problem of its 2 factors. One is a linear factor and the other one is a quadratic. If it's factorable, that makes it easy. If it's not factorable, you need to go to the quadratic formula to find the other 2 factors.